Hi students, today we're going to do section 1 of chapter 8. Dissolving. The solution, if you remember back to chapter 2, is a homogeneous mixture of two or more substances. In a solution there's two parts. You have the solute, which is the substance being dissolved, and you have the solvent, what the solute is dissolved in. So if we are talking about Kool-Aid, there's three things in Kool-Aid. There's the sugar, there's the Kool-Aid powder, and there's the water. The sugar would be a solute because it is being dissolved, as well as the Kool-Aid. Both of these are being dissolved, and so these are solutes. Whereas the water is the solvent. There are three different methods to dissolve in water, and it depends on what type of substance you have. The first is dissociation. It occurs when particles in an ionic compound separate to form individual ions. For example, sodium chloride in water. So anytime you have an ionic compound, they dissolve by dissociation, and they form individual ions. Like if you see in this picture, sodium, this is the sodium chloride, and it's breaking up into the sodium ions and the chlorine ions with water surrounding it. The next way is dispersion. Dispersion is the process of splitting into small pieces that spread throughout water. This is how covalent compounds dissolve. For example, candy on your tongue, or sugar in water. So if this is your sugar molecule, and the water is going to just make them into very small molecules, but it's not splitting up the molecule at all. It's just breaking them into really small pieces. The next way is ionization. This is a process by which neutral molecules gain or lose electrons, and this is how acids, so hydrochloric acid, will dissolve. We've got hydrochloric acid here, and if you add water to it, what happens is one of the hydrogen from the acid gets added to the water, and then you end up having a chloride ion afterwards. Properties of liquid solutions. Properties of solutions can differ from those of its solute and solvent. For example, conductivity. Pure water by itself is a poor conductor. I'm not talking about water that comes out of a sink, because water that comes out of a sink has ions in it. But if you have pure distilled water, it is a very poor conductor. But when you have salt or other solutes dissolved in water, it can become a good conductor. Freezing point also lowers. For example, you add antifreeze to gasoline so that it will lower the freezing point of gasoline so it does not freeze when in the cold. And boiling point increases. Heat of solution. When making a solution, energy is either released or absorbed. Factors that affect the rates of dissolving. These are very similar to factors that affected reaction rates, so it is similar. Surface area. The greater surface area increases the rate of dissolving. Stirring increases the rate, which is why you stir Kool-Aid. An increase in temperature increases the rate of dissolving. And that is it for today's notes.